Hey guys, my name is Jerry Yang, and I'm going to be doing the 2022 Math Kangaroo Level 3 and Level 4 answers. So, with that, let's just get started. Our first question is Buzz the Bee wants to reach the flower. Which set of directions will get him there? Now, what we could do is try out all of these options and see which one works. But what would be smarter and which is what is a better approach is to figure out what combination we want. So, if we look at this, we want one, two, three right arrows and one, two, three down arrows. So knowing that, we need some sort of combination to get us from here all the way to here. But it doesn't matter which combination as long as it gets us there. So let's see. So with A, we have one, two, three right arrows. So that's correct. And then we have one, two, three down arrows. So we know A is an option. With B, we have one, two, three, four down arrows, so we know B is not an option. With C, we have only two down arrows, so we know C is not an option. With D, we only have two right arrows, so we know D is not an option. And with E, we have four down arrows again, so we know E cannot be the answer. So knowing all of that, we know that A is the only viable answer here. So our answer for question one is A. So our second question is asking, laser beams reflect in the mirrors in the way shown in the first picture. At which letter will the laser beam in the second picture end? All right, so we know they gave us this general pattern and they want us to apply it. So if we notice about this pattern, it basically just follows the grid line. So every time it hits one of these diagonals, it follows the grid line that allows it to continue. So over here, we start over here and then we go down, then we go to the right, then we go up, and then we go to the right again, and then we go down. And it might seem a little confusing over here because now we're not following this general pattern. But what happens is, obviously, you can't continue over here or over here. So you must continue over here, and then you reflect down, and then we end up at B. So we know that our answer for this question, question number 2, is going to be B. So question number 3 says, Rosita wants to put 2 coins in each row in each column of the grid. Which coin does she need to move to an empty cell? So let's start by checking all of the rows and all of the columns to see which ones are missing coins or which ones have extra coins. Starting with the rows. So let's see. We have 2 coins in this one. All right, pretty good. 2 coins as well in this one. 2 coins. Ooh, and then 1 coin and then 3 coins. All right. So we know that one of these 2 coins has to be moved because this coin can't be moved or else there'd be 0 coins there. This one has 1 extra coin, so either C or E has to be the coin we move. Next, let's look at our columns. First of all, we have 3 coins already, and then 1 coin, and then 2 coins, and then 2 coins, and then 2 coins. Okay, so then we know out of these 3 coins, one of these 3 has to be moved in order for it to moved over here in order to make sure we have an equal number of coins in each row and column. And wouldn't you look at that, huh? The only coin that overlaps in these 2 areas is coin C. So we know that we got to move coin C in order to make everything equal. So our answer for question number 3 is going to be C. Next up, question number 4. Question number 4 says, what is the smallest number of boxes that Bill has to move to be able to open the train box? So which one is the train box? That's this box over here. So that's the box that we got to figure out how to open. And they want us to see how many boxes we got to move. Well, let's work down to up. So let's look at this. We need to move these 2 boxes because these 2 boxes are on top of it. So we know, let's have some tally marks. We have 2 boxes so far that we need to move. In order to move these boxes, right, we got to take 1, 2, and this third box. So then we have to add 1, 2, 3. And then after that, we can see that if we take out these boxes, we take out these boxes, then we can access our train box. Because, I mean, if we look at these boxes, right, we don't need to take out puzzles or books in order to access train because those aren't on top of it or aren't on top of the boxes on top of train. So therefore, we know that we literally just need to move 5 boxes, and that makes our answer for question number 4, C. Next up, we got question number 5, which says that Kangaroo always makes one large jump followed by two small jumps on the number line as shown in the picture. Kangaroo starts at 0 and ends on 16. What is the number of jumps that Kangaroo makes? So we know we got one large jump followed by two small jumps. That's shown on this number line over here. So let's start by figuring out how much distance is covered by one large jump and how much distance is covered by one small jump. So this is our large, these two are our small jumps. So we know a large jump covers 2 units, and then each small jump covers 1 unit. So we know that in 3 jumps, every 3 jumps, Kangaroo covers 4 units. Now, knowing this conversion rate, now we got to figure out how many jumps it takes Kangaroo to cross 16 units. So in order to do that, let's first start by dividing 16 by 4, because it's 16 units divided by 4 units, and then multiplying by 3, which is the amount of jumps, in order to get 12. So if you're confused with that math, this 16 over 4 becomes a 4, and then you multiply by a 3 in order to get 12. So we know that the number of jumps that Kangaroo needs to make in order to cover 16 units is 12 jumps. Question number 6 says Anna makes a puzzle where 2 squares with common sides do not contain the same number. Which piece should she use to complete her puzzle? So first of all, let's mark out all of our squares. And then let's start with this square, right? So we know that this square cannot have the numbers 3 or 5. So the possibilities are 1, 2, and 4. So out of all of these options, this one still works. This one still works. This one still works. This one still works. But E no longer works because it has a 3 up at the top. So we already eliminated one answer choice. That's pretty good. Next up, let's check out this box, right? So we know this box has a 1 and a 4 over here. So it cannot have a 1 or a 4, but it can have a 2, a 3, and a 5. So now let's check all of our options. And we know, answer choice A, we can already eliminate because it had a 1 there. Right, this one has a 3, that's good. C has a 4, so we can also eliminate that because there's a 4 right here. And then now we're left with B and D. Now, with this third square, we eliminate the options of 2 and 5, meaning that we only have the option of doing 1, 3, and 4. So let's check our answer choices. 1, 3, 4. 4 is right there. 1, 3, 4. You can have a 1. All right, so now we're down to our last square. So it's all up to this final square to see what our answer choice is. And with this final square, I don't know if you guys saw that. Here, I can go back. We have 2, 3, and 5. So that actually narrows our answer choices down to only 2 possible numbers, which are 1 and 4. Now, looking at our answer choices, at the final one, this one has a 2. All right, so we know it cannot be answer choice B. And just to verify, D has a 4 right here. So we know it can be answer choice D, and that's the only answer choice we have left. So the answer for question number 6 is D. Question number 7 says, which 2 numbers can be written in the 2 boxes to make the statement correct? And the statement we have up here is 2022 plus blank equals 2020 plus blank. Now we know that whatever this number is and this number is going to be 2 less than whatever it is. So if this is x, then this is x minus 2. And we can use that as our only basis for all of our answer choices, right? So let's see. So 3 is indeed 2 less than 5. So we know A is a potential option. 4 is not 2 less than 1. So we know B is not an option. 3 is not 2 less than 4. So we know C is not an option. 7 is not 2 less than 2. So we know D is not an option. And 9 is not 2 less than 8. So we know E is not an option. So this one, pretty simple. The answer has to be A because none of the answer choices work just based off of the variables that we have here. All right, so question number 8 says, John builds the tower shown. What will he see if he looks at his tower from above? And this is our tower over here. That's the figure that we're looking at, right? So first of all, let's think about it and let's draw what we think it'll look like. So we know we have a tiny little square in the middle, so that's our tiny little square. And then we have a slightly bigger one, huh? So somewhere around the middle between this one and the large one, and then we have a large one. So we know our diagram is gonna look, something like this, right? So we know we're gonna have one, two, three layers. So first of all, we can start eliminating with that. So with this, we have one, two, three, four layers. So we know it cannot be A. With B, we have three layers. So that's possible. C, we have three layers. Also another possibility. D, we have two layers. Not an option. And E, we also have two layers. Not an option. So now we're down to B and C. So out of those two options, if we look at this and we look at how far away this second square is from the first square and from the third square, if we kind of look at just eyeball it basically, we can see that it's about halfway between the large square and the small square, like I said earlier. So we know it really can't be B because this square is way too tiny for what we're looking for. So we can eliminate B, and we know our answer for question number 8 has to be C. All right, now we're getting into the 4-point problem. So these ones are going to be a little bit harder. So let's start with question number 9. Question number 9 says 5 cars numbered 1, 2, 3, 4, and 5 are moving in the same direction. First, the last car, number 5, passes the 2 cars ahead of it. Next, the second to last car passes the 2 cars ahead of it. Finally, the middle car passes the 2 cars ahead of it. In what order are the cars now? Now, a tricky thing about this problem and what they're trying to get you to do is you might think that the second to last car is going to be number 4. But as we write out all of these sequences, you'll realize it's not going to be number 4. And the middle car is probably not going to be car number 3 either. So with that, let's get started. So let's start with our starting arrangement. We have 1, 2, 3, 4, 5. So pretty basic. The last car passes the 2 cars ahead of it. So 5 goes up here. Then we have 1, 2, 5, 3, 4. So not that big of a difference. But now the second to last car passes the 2 cars ahead of it. Second to last car is now car number 3. So it passes car 5 and car 2. And now our order, if we go up here, is going to be 1, 3, 2, 5, 4. So you see how it's kind of tricky because car 4 is no longer the second to last car. And then finally, the middle car passes the 2 cars ahead of it. And in this case, the middle car is now car number 2. So car number 2 passes car number 3 and car number 1. And now we have our order of 2, 1, 3, 5, 4. So that's our final order. And out of all these options, so this one doesn't start with 2, so we know it's not A. This one is 2, 1, 3, 5, 4. B is going to be our answer. Just in case. We'll check these other ones. 2, 1, 5. No, this 5, so it's not. And then it starts with a 3. That's not correct. Starts with a 4. That's not correct either. So we know our answer for question number 9 has to be B. Next up, we got question number 10. The ages of a family of kangaroos are 2, 4, 5, 6, 8, and 10 years old. The sum of the ages of 4 of them is 22 years. What are the ages of the other 2 kangaroos? So you know what? To start this off, what we can do is add up all of these numbers. So we got 2 plus 4 plus 5 plus 6 plus 8 plus 10. So adding up all these numbers, let's just start grouping them. So this is 18, this is 11, this is pretty basic addition, 6, and then we add these 2 up, you get 17 plus, and then we take the 18 over, plus 18 equals, 35. So we know that the total ages is going to be 35. But now we got to figure out, right, what are the ages of the other 2 kangaroos that are not part of the 22 years? So then what we need to do is we need to do 35 minus 22, which equals, what does that equal? Let's see. That equals 13. So then we got 13. So we know the sum of the other 2 ages has to be 13. So we can judge all of our answer choices based off of that. So for A, the sum is 10. That's not true. Then for D, the sum is 14. It can't be D. For B, the sum is 9. It can't be B. For E, the sum is 16. It can't be E. And that leaves us with C. And 5 plus 8 is, in fact, 13. So we know that our answer for question number 10 is going to be C. Right, next up, we got question number 11. During my vacation, I sent the 5 postcards shown below to my friends. Now, before we keep reading, I'm actually going to skip over to the question, and this is a good habit to get into. Because if you skip over to the question, especially for these long questions, you'll know what you should be looking for. So the question they're giving us is, which card did Mike get? So using all these conditions, we got to figure out, what card did Mike get? So now let's start reading the conditions. There are no ducks on Mike's card. Okay, well, that makes it pretty easy. It cannot be D because there's ducks right there. Kara's card has the sun on it. Now, this is interesting because there's 2 cards with suns on them. So they might be trying to trick us. So I'm not going to cancel out A yet because there's a possibility that this is Kara's card, right? There's exactly 2 living creatures on Paula's card. Okay, well, B and C both have 2 living creatures, so it's hard to cancel those out yet. Lexi's card has a dog on it. Okay, so we know E is Lexi's, so we know that Mike can't get that one. And there are kangaroos on Heather's card. Well, I don't know about you, but these look a lot like kangaroos to me in postcard B, so I think this is Heather's card, and then we know that means this is Paula's card, right? So this is Paula's card, and that only leaves us with A. And we know that Kara's card has a sun on it, and because D has a sun on it, it's pretty safe to assume that Kara's card is D. So then we know that out of these 5 postcards, the card that Mike got has to be card A. So the answer for question number 11 is going to be A. All right, we got question 12, which says, George wanted to take the sum of the 3 numbers in each row and each column of the grid to be the same. He made one mistake. Which number must he correct? So this is pretty simple. Let's just go through all of the columns and all of the rows again like we did before for a previous problem. So let's start with the rows. 9 plus 1 plus 5 is 15. Then 3 plus 7 plus 6 is 16. Okay. And then 4 plus 7 plus 4 is 15. All right. So already we can see that the number we probably want is going to be 15. So something in this row right here, one of these numbers, we're going to have to change. But let's look at the columns. 9 plus 3 plus 4 is, 16. Then 1 plus 7 plus 7 is 15. And 5 plus 6 plus 4 is 15 as well. So now we know one of the numbers in this column has got to get changed. And would you look at that? What overlaps between this row, and this column, but the number 3? If we look at our options, we got A, B. Oh, B says 3. So we know our answer for question number 12 is going to have to be B as the number he needs to correct. Question number 13 says, Aladdin has a square carpet. There is the same number of dots arranged in 2 lines along each of the 4 sides of the carpet. Unfortunately, one side of the carpet got folded over. How many dots are there on Aladdin's carpet? So let's start by counting how many dots, right? 1, 2, 3, 4, 5, 6. So we know there's 6 on the outside row, ring, and then on the inside ring we have 1, 2, 3, 4 right here, 4. So we know that if we replicate this, right, we got 1, 2, 3, 4, and then we got 1, 2, 3, 4, 5, 6. And then up here we got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 down here, and then we got 1, 2, 3, 4, and then 1, 2, 3, 4 over here. So now if we just count up all those dots, it should give us the amount of dots that are on Aladdin's carpet. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 on the outer row plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 plus 12. And that gives us 32 dots. And that gives us our answer for number 13 as E. Alrighty, next up we got question 14. Joanna folds the number square twice as shown. Then she punches a hole through the black spot shown by the arrow. Which numbers does she punch through? Now, if we basically unravel her folding, we see that we got this hole punched out and this square punched out. And because we know it got folded along this axis, that means that the numbers she punched out are going to be this number and this number and this number and this number. And those numbers are 14, 20, 17, and 23, right? So let's go through all of these options and see, which one is correct. So A, okay, we know that 8 is not one of the numbers that was punched out, so that's wrong. We got 14, that's correct. 16 is not one of the numbers that was punched out. Then we got 14, 17, 20, 23. Okay, so then we're pretty sure that B is our answer. But just in case, let's check all of the other options. 15, okay, we know 15 was not punched out. 15, we know 15 was not punched out. So we know that our answer for question number 14 has to be B. Next up, we got question number 15. The students in the class sit in rows. There is the same number of students in each row. That's important. There are 2 rows of students in front of Robert and 1 row of students behind him. In his row, there are 3 students on his left and 5 students on his right. How many students are there in this class? So let's start by drawing Robert. He's kind of in this central position, and we're going to branch out from where he is. So there's 2 rows in front of him, and there's 1 row behind him. And in his row, there's 3 students to his left and 5 students to his right. So let's just make sure 3, 5, 2 in front, 1 in back. Alrighty. Now we know since there's the same number of students in each row, we just count the row and multiply it by 1, 2, 3, 4. We'll get the amount of students in this class. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 students per row, and there's 1, 2, 3, 4 rows. So we know 9 times 4 is going to be 36. So we know our answer for question number 15 is going to be E, 36. Question number 16. The cube in the picture is built using 3 kinds of wooden blocks shown. How many white wooden blocks are used? Now, your first instinct might be to try and, map out this figure in your head and figure out, okay, where do these pieces match up and try and count it in your head. But actually, what's much smarter is if we break all of these pieces down and figure out how many units they take up, right? So let's say this block, this white block, is 1 by 1 by 1 unit, right? Then we know that this gray one is going to be 3 of these white ones. And this light gray one is going to be, if we split it up here, then we see it's 1, 2, 3, 4, 5. So this one's going to be 5. So we got one that makes up 5 units, one that makes up 3 units, and one that makes up 1 unit. And we're trying to figure out how many of the 1 unit ones we need. Now in this cube, it's a 3 by 3 by 3. And we can see that because, this is 3 and this is 3 and this is 3 and all these sides are equal, right? So then if we know that, then we know 3 times 3 times 3 is 27. And if we look at this, right, we can see that there's 1, 2 of these dark gray ones. So if those take up 3 units, then we have 2 times 3 plus, and then we have how many of these light gray ones? We have 1 showing here and then 1 showing here. And don't be tricked either. This one showing up here is actually the same one that's showing up here. It's just, if you think about it, it's going like this. It's going like an L behind where we can't see. So actually, there's only 2 of these light gray ones. So then we get 2 times 5 because we know that from over here. So we get 5 over here. And then we know that equals 16 because this is 6 and this is 10. You add those, that's 16. So then we do 27 minus 16 and we get, what do we get? Well, we get 11. So then we know that all the rest of the missing blocks have to be made up of these white ones. So we know that there gotta be B or 11 white cubes that are being used. So we know our answer for question number 16 is gonna be B. All right, now we're getting to the big problems. These are the 5-point problems. These ones are worth quite a bit. So starting with problem number 17, Wanda chose a few of the following shapes. These are the shapes. And said, among the shapes I chose, there are 2 colored shapes, 2 large shapes, and 2 round shapes. What is the smallest number of shapes that Wanda could have chosen? And these are our answer choices. Let's see, right? So 2 round shapes, that one's probably the easiest. So we know we got to choose these 2 because, triangles and squares aren't exactly round. 2 large shapes. So then we're given the choice between a triangle and a square. But what we should really be thinking about is 2 colored shapes alongside 2 large shapes, right? Because we know we got 1 large shape and 1 colored shape. But if we think about it, if we choose just 1 square, doesn't that satisfy our requirements? Right? 2 colored shapes. Let's see. We got a colored square and a colored tiny circle. Seems to satisfy it. 2 large shapes. We got a large square and a large circle. That also satisfies the conditions. And obviously, 2 round shapes, we got big circle and little circle. So, what is the smallest number of shapes that Wanda could have chosen? Well, it's 1, 2, 3. 3 shapes. So our answer for question number 17 is going to be B, 3 shapes. Question number 18. 3 football teams participate in a sports tournament. Each team plays the other 2 teams exactly once. In each game, the winner gets 3 points and the loser doesn't get any points. If the game ends in a tie, each team gets 1 point. At the end of the tournament, which number of points is impossible for any team to have? So because each team plays the other 2 teams exactly once, we know we only have 2 games for each team. So you have to get to these numbers in 2 games, or you can only add, 2 different numbers. So for A, this one's pretty simple. That means 1 tie and 1 loss, right? So A is possible. B means 1 tie and another tie. So that's also possible. C could be 1 win and 1 tie. So that's possible. D, D you can't really make, right? You can't do 3 and 2. You can't do 1 and 4. So actually, D seems to be the one that's impossible, but let's just check and make sure, right? So for E, we can, you can make that. You just need 2 wins, right? 3 and 3. So we know that our answer here has to be D because there's no way you can get 5 points just by adding two numbers or just through 2 games. So our answer for question number 18 is going to have to be D. Right. Question number 19. A pyramid is built out of cubes. Each cube has a side length of 10 centimeters. An ant climbed up and over the pyramid, as shown by the red line. What is the length of the red path the ant walked? All right. So let's just start with the view from above, right? A lot of you might be tempted to add up each of these individual segments, but that seems kind of like a lot of work, huh? But if we look at it just from the top, what we can realize is that across the entire thing, this entire red line is just 30 centimeters, right? Because if this is 10, and this is 10, and this is 10, 10 times 3 is 30. So 30 centimeters just crossing the top. But then we got to think about the sides, right? The ant isn't just crossing straight through all the boxes. It's got to climb up and on top of and down the boxes. So then we got 1, 2, 3, and then 4, 5, 6. You can't see these sides, obviously, but they're there. So we got 6 sides that it's got to go up or down. And that length that it's crossing every time is also going to be 10 centimeters because these are cubes, right? So if we have 6 times 10, that equals 60, right? And knowing that, then we got 60 plus 30, which we know has to equal 90 because, that's how addition works. So if we look at all our answer choices, we know that E is our answer to question number 19. Alrighty. Question number 20. Alma wants to put one of the pieces shown in the middle of the picture so that a child in house A is able to travel to house B and to house E, but not to house D. She can rotate the pieces. Which two pieces could she use? All right. So we know that we got to connect all of these 3 houses and make sure D is not included. So what 2 pieces can we use? Let's just start testing the pieces, I guess. So piece number 1 would, if we installed it, we would have to rotate it a little bit and it would look something like this. And yeah, that seems to work. From A, you can get to E, from A, you can get to B as well. So that actually does seem to work. So we know that 1 actually is a viable option. So now let's try piece number 2. And quickly, we actually realize, piece number 2 doesn't really work no matter how you rotate it, right? If we put it in this configuration, right, you still can't get to D, but you also can't get to E. And then if we put it in a different configuration, well, now we can get to E, but then we can't get to B. So piece number 2 actually, it doesn't work. Let's try piece number 3. So piece number 3 would look something like this if we implemented it. And immediately we can see there's a little bit of an issue because there's only 2 ways you can really put piece 3 that are unique. And this is one of them. And here you can see you get E, but you don't get B. If we put it in the other configuration, well, now you got B, but you're not even connected to A or E. So yeah, piece number 3 doesn't work either. Piece number 4. Now, piece number 4 looks kind of promising, but remember, looks can be deceiving. So let's test this out, right? If we put it, let's say we have one like this, then what we would have is another piece. Here, let me try and figure this out. If we had a piece like that, you would have to have a piece something like this. Yes? Yeah, that looks about right. But then quickly we run into this issue, right? Obviously, now child A can get to B and E, but suddenly D is in the mixture. We don't want house D, right? And then if we try any other configurations, right? Now you're just cutting off house A, right? House A can't get anywhere from here, even if you're cutting off house D. We realize it's actually because of the design of the road, because if you see, it just connects 2 things that are 2 roads, 2 houses that are across from each other, and D is across from A. So piece 4 really is not going to work. And it actually kind of works out because it kind of looks like an X. So finally, we got piece 5. We got to hope piece 5 works. And pretty soon we realize, piece 5 does work. Because what you have is you have a connection like this. It's kind of like a fork, right? You have to rotate it a little bit this way. But if you look at it, piece 5 does work. Because then you're connected to E, you're also connected to B, you're also connected to A. And most importantly, D is not in the mixture. So we know that the 2 pieces that she can use are piece 1 and piece 5. We've looked at all the options, A, B, C, D. Option E has 1 and 5. So we know our answer for question number 20 has to be E. Next up, we got question 21. Ahmad and Zayla start moving from point A with the same speed in the directions shown. Ahmad walks around the square-shaped garden, and Zayla walks around the rectangular-shaped one. They meet again at point A. What is the smallest number of laps around the square-shaped garden that Ahmad can make to meet Zayla there? There as in point A. So let's call this square A, and this is rectangle Z. So we know square A has a perimeter of 20 because, 5 plus 5 plus 5 plus 5. And then Zayla's rectangle The perimeter is 10 plus 5 plus 10 plus 5, which is 30. Now this is interesting. They want us to figure out how many laps it takes Ahmad to meet Zayla there. So that's important to remember. We don't want to mix up the two. So just looking at this, we see that we have 20 and we have 30. And the number that they meet next at is going to be 60. So this is important to know because this means that Ahmad has to take what? 60 divided by 20, which is 3 laps, and Zayla has to take 2 laps. But we only care about Ahmad's laps. So if we look at our options, we see, oh, option C is 3. So we know our answer for question number 21 has to be C. Question 22. 5 girls ate some plums. Lauren, and I'm going to write out these equations as we go. Lauren ate 2 plums more than Sophie. So Lauren equals S plus 2. Then we got Betty ate 3 plums fewer than Lauren. So we got L minus 3. Then Claire ate 1 plum more than Betty. And 3 plums fewer than Alice. So we also know C equals A minus 3. Which girls ate the same number of plums? Let's see. So we know that all of these are going to be unique numbers except for 2 of them. So what we can do actually, since we already have two equations that talk about Claire, let's just continue with Claire. So let's see. We can't plug in A because we're not given Alice anywhere else, but let's plug in Betty. So then we get C equals L minus 3 plus 1. Now what does that tell us? That means C equals L minus 2. Now that doesn't really match up with anything else now, does it? But let's plug in L from here. Let's plug it in over here. Then we get C equals, S plus 2 minus 2. Oh, that's interesting because those two cancel out. Then we get Claire has eaten the same amount of plums as Sophie. So that's interesting because that gives us the 2 girls that have eaten the same number of plums, Claire and Sophie. So if we look at our answers, we got Claire and Lauren. Oh, Claire and Sophie is option B. So we know that our answer for question number 22 has to be B. All right, next up we got question 23. The small caterpillar shown in the picture curls up to sleep. What might it look like? And I've changed my pen color to red just so that we can see it on all of these colors. And what this is testing us on is the different patterns that we can recognize. So we know our pattern is going to be orange, black, yellow, black, yellow, black, yellow, black. So it starts on orange, ends on black, and it's alternating. Kind of like, think about it like a bee. So let's start with option A. So option A, we go orange, black, yellow, black, yellow, black, yellow, black. So if I draw that out for you, it looks something like that. So this is actually a viable option. So A is a possibility. Next up, we got B. We got orange, black, yellow, and then we can't get to the black over here because, caterpillars don't work like that. You can't just, transcend this segment of the caterpillar. So we know that it can't be option B. Option C, let's test it out. So we got orange, black, yellow, and then if we go black here, then we're kind of stumped. But then we can't really do anything if we go here because there's no blacks over here. But let's just try the other way. So we got orange, black, yellow, and then we can't get to either of these 2 blacks either because this yellow is blocking us. So we know that option C is not possible either for how the caterpillar would look. Now with option D, we have orange, black, yellow, black, and then we're kind of stumped over here again, because these two blacks are blocking us. But just in case, let's try the other way. So we got black, or we got orange, black, yellow, and then we're also stumped again. Because, if we look over here, we're trying to get to this black, but this yellow is blocking us. And like I said before, you can't just skip a segment of the caterpillar and come back to it. So we know D is not an option either. Finally, we got E. Let's test E out. So we got orange, black, black. Ooh, that's not possible. Orange, black, yellow's over here. You can't access that yellow. But once again, like the other options, let's try the other way. We got orange, black, yellow, black. And then you can go either yellow, but if you go this yellow, the next black segment's all the way over there. And if you go with this yellow, well, then you go yellow, black, and then the next yellow's all the way over here. And because you can't just skip segments like that, we know E is not an option either. So we know that for question number 23, A has to be our answer. All right, final question, question number 24. In the grid, the same number is hidden under the same color square. To the right of each row, the sum of the numbers hidden under the squares in that row is given. Which number is hidden under the black square? So you know what? I'm going to make this a whole lot easier. I'm going to make this X. I'm going to make this Y, 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 X, X, X. This is an X. Okay. So knowing that, we know X plus 2Y equals 34. We also know that on this bottom row over here, Y plus 2X equals 26. So knowing these two numbers, you might be thinking, okay, let's split up and let's solve for both of these variables. No, that's not what you should do. Because if we look at over here, what we have is we have X plus Y plus mystery number equals 32. So all we really have to solve for is not X and Y individually, but if we solve for X and Y together, we can also find what our mystery number is. And we can actually do that very easily, and they gave us like the perfect setup for this. So if you add up these two equations, what we actually get is if you add these two, and you add these two, we get 3y plus 3x equals, what does this add up to? Adds up to 60. Wow, isn't that really convenient, huh? And then if we divide everything by 3, we divide this by 3, and we get y plus x equals 20. And then without solving for y or x individually, we plug in 20 here, and then we get 20. Oh, let me move this down. 20 plus mystery number equals 32. And all we have to do is subtract 20 from both sides. Subtract 20. Then we get mystery number equals 12. So actually, all we got to do now is come back up here. Look at our options. What are our options? So we know for our number 24, the final problem, our answer has to be D, 12.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!